Hello everyone, my name is Pei. Today I will present a tutorial of how to perform the non-negative matrix factorization using Python. So I have two goals for this tutorial. First is to show how to create non-negative matrix factorization model in Python. Second is building the recommender system by using non-negative matrix factorization. So there are several NMF libraries in Python. In this tutorial, I will use scikit-learn library because it's widely used for machine learning and data mining tasks. So the scikit-learn decomposition NMF function can find two non-negative matrices whose product approximates the non-negative matrix. So this factorization can be used for dimensionality reduction, source separation, or topic extraction. So now I will introduce several major parameters for this function. The first is n components. So it's the number of components, and if it's not set, all features are kept. The init is the method used to initialize the procedure. L1 ratio is the regularization mixing parameter. So its range is 0 to 1. And the tolerance is the tolerance value used in stopping conditions. And max iter is the number of iterations to compute. Alpha is constant that multiplies the regularization terms. In this tutorial, the movie tweetings dataset is used. It's an automatically updated dataset from Twitter. So it has about 600,000 ratings, more than 48,000 unique users, and 27,000 unique movies. Now, let's begin the tutorial. So first step is loading the data. So to make it easy to compute and understand, 15 movies and 20 users are randomly selected. So we can see 0 in this rating matrix means no rating. Next, we can use the NMF function to create the NMF model with desired parameters. So for this example, I set n components equals 2, init equals random, max iteration equals 200, and alpha equals 0, L1 ratio equals 0. So by using the fit transform attribute, we can get the movie latent features, and by using the components feature, we can get component attribute, we can get user latent features, and the reconstruction error attribute gives us the difference between the training data and the reconstructed data from the fit produced by the model. So from the output, we can see the error of this example is about 43.81. So the next step is predicting the ratings of unrated movies. So in order to predict the ratings, the dot function is used, and it gives us the dot product of movie latent features and user latent features. So after dropping the ratings of movies that user has already rated, we get the predicted ratings of unrated movies. So here is the output. It's the predicted ratings of unrated movies for 5 users. So now we can recommend movies to a certain user by defining the function recommend movie. So for example, we want to recommend 3 movies to user 922. So in this function, predicted ratings of unrated movies are sorted, and the index of 3 highest predicted ratings are selected. So here is the output. It's the movie ID of the top 3 movies with the highest predicted ratings for this user. So at this point, we have successfully built the NMF model and the recommender system. Now we can tune several parameters to improve the model. So in this tutorial, I tuned these 5 parameters. They are N components: init, max iter, alpha, L1 ratio. So the grid search is used to find the optimal combination of parameters. Here is the output. So the output shows us the 5 combinations with largest error and 5 combinations with the smallest error. So we can see when n components equals 14, init equals NNDSVDA, max it equals 200, alpha equals 0, L1 ratio equals 0. The error is smallest. So we can use the tuned parameters and repeat the step 2 to step 4. So we can have a better recommender for a certain user. Based on the output in the previous slide and the graphs in this slide, several conclusions can be drawn. The first is increasing number of components decreases error but increases runtime. For this small dataset, NNDSVDA has better performance compared with other methods. Next, error decreases with the increase of iteration, but it can stop decreasing when max iteration equals 75, as shown in this graph. So when we set the number of components or the max iteration, we need to consider the trade-off between runtime and error.